Alright guys, so today is day 2 of linear inequalities. So again, we're going to be talking about the same thing, the whole shading above or below the line, and then solid or dotted. The only thing I was nice enough yesterday, I gave it to you guys in y equals mx plus b form. Okay, today I'm not. Today I'm actually going to give it to you guys in standard form. So here's something you want to copy down, right? This is a quick cheat sheet of everything we kind of learned yesterday. How do I know if it's a dotted line? Well, it's a dotted line, right, if it's not equal to. So if you just have something like greater than or something just like less than, that's how you know it's a dotted line if you go down this column. Solid line, that's when it's equal to, so something like greater than or equal to or less than or equal to, you're going to have a solid line. Now, shading above, well, if you have greater than or equal to, we shade above the line, and if you have the opposite, of course, you're going to shade below. So this is something you want to copy down. You can always reference it to help you out. So let's jump into the first example here. It says graph 5x minus 3y is less than 6. Now notice it's in standard form. I'm not nice enough today to give you guys in y equals mx plus b, so I have to fix this. Now the way that I fix this is I say, hey, I need to move over first dx because I want that y all by itself. So this is a positive 5x, so we say minus 5x minus 5x. Okay, these guys cancel out. Now don't forget, you're going to bring down the negative with the 3 and the y. So this is negative 3y is less than, and you can't combine these. This value, the negative 5 has an x, so we say negative 5x. And that's a positive 6, so plus 6. Now you have your mx plus b, but you still have that negative 3 out in front. Now again, you're multiplying here, so the way that you get rid of it is to divide. Now again, don't forget when you're dividing, you gotta divide everything by not just the 3, but a negative 3. So this gets divided by a negative 3, that gets divided by a negative 3, that gets divided by a negative 3. So the 3's will cancel out, you get 1y. Now here's the thing, I divided by a negative, right? And if you remember, whenever I have an inequality sign and I divide by a negative, or I multiply by a negative both sides, I have to flip that inequality sign. So this guy's actually going to become now greater than. This is one of the the new things that comes up, and we know this already from previous examples. So here we have negative 5 divided by negative 3. Well, negative divided by negative is a positive, so I can simplify that. Can I divide 5 by 3? No, and that's okay. I can leave it as a fraction because that's going to be my rise over my run. All I did was negative divided by negative is a positive. Don't forget to bring down your x. That's very important. And now positive divided by negative is a negative. 6 divided by 3 is 2. Hey, this is nice. I can actually jump right into my graphing now. Okay, so I do need you guys to draw your x and y planes. All right, I'm going to do this as best as I can. Okay, so I'm going to do this in a different color here. I always want to start with my y-intercept, which is my b. Here I have to go down to negative 1, negative 2. Okay, now my slope is telling me that I have to go, because it's positive, I have to go up 5 and over 3. So I'm going to go up 1, 2, 3, 4, 5, and across 1, 2, 3. So here's my second point. Now again, this is what we were used to, right? Now you have to ask yourself, hey, is this a dotted or a solid line? And it all depends on that inequality here. Now, because I'm not equal to it, I can't stand on the line, so it has to be a dotted line. You have to go through here, dotted line, extend this out pretty far, arrows on both ends, because it keeps it going on forever. Now this shading, am I going to shade above or am I going to shade below? Now this is saying y is greater than, so that means I'm a shade above the line. So again, if you were to actually pick a point here and just kind of point up, well, this is the side that you have to shade everything above this line. I'm going to try to highlight it here as best as I can. All of this gets highlighted. All of this gets highlighted. This is again representing all of my solutions. All of this area here represents all my possible answers that would make this inequality a true statement. Okay, now again, that was the one type of question I can ask you guys. Here's the other type of question that I can ask you is give 3 possible solutions. So I'm going to have to flip back and forth here in a second, but it says give 3 possible solutions for the one that we just graphed. If I go back here, what are 3 possible solutions? Again, it's basically any points that fall in over here on the left side. Everything above here, everything that's highlighted represents all my solutions. So let's give, I don't know, let's say negative 1 and I go up to 2. This would be a solution. It lands negative 1, comma 2. Lands in my, that should be a 1, it's kind of hard to write, lands in my shaded area. What's another solution? Well, I can say, hey, negative 1, 0. Yeah, absolutely, negative 1, comma 0. I don't know why this thing is laggy. All right, there we go. Now, I can go all the way to the left here. I can say negative 1, negative 2, negative 3, negative 4. Let's say negative 4. comma, let's say positive 3. Yeah, let's go up here. What if I say negative 4, comma, 3? Yeah, all these points here lie in the shaded area and the highlighted area here. So that represents these are all possible solutions, all possible answers. All right, so keep that in mind if I ever ask you guys to give me 3 possible solutions. And of course, this is the same equation we just finished graphing. All right, it doesn't copy over, so I have to flip back and forth. Okay, so what I want you guys to do is pause the video here for example 2. Try this out on your own. Okay, and then resume in a second. All right, guys, so same thing with this one. I have to change it. It's in standard form. So how do I fix this? Well, again, move over your x first. You got to get that y by itself. So I'm going to say minus 3x, minus 3x. These guys cancel out. I'm left with, don't forget that negative. Negative 2y is greater than, and again, I can't combine those. One of them has an x, one of them doesn't. So I'm going to put negative 3x, and that's a positive 2. So I say plus 2. Now again, how do I get rid? I'm multiplying here by a negative 2. The way that we get rid of multiplication is division. So I divide by negative 2, divide by negative 2, divide by negative 2. And yes, I divided by a negative. I divided both sides of the inequality. So that means that this guy's going to flip in a second. So these guys cancel out to give you simply 1y. Now, of course, I divided by a negative 2, so I do have to flip my inequality sign. It's only when you divide by negative, not when you subtract, right? Only if you divide by negative or you multiply by negative. So please make that distinction there. Now, a negative divided by negative is a positive. So can I divide 3 by 2 though? No, and it's okay. I'll leave it as a fraction. It's okay. It's my rise over my run. X. What's a positive divided by a negative? It's a negative. 2 divided by 2 is simply 1. Hey, that's y equals mx plus b. I'm good to go. I can already start to graph this guy here. All right, so this one, again, let me use a different color so it stands out. This one's telling me my b value is negative 1. So on the y-axis, I want to start at negative 1. Okay, now my slope is 3 over 2, so I rise over my run. I'm going to go up 3 because it's positive. Remember, if it was negative, I'd go down. But I'm going to go up 1, 2, 3 over 2. Okay. Now, solid or dotted line. Well, again, I'm not equal to it, so I cannot stand on there. It's going to be a dotted line that's running through here. All right, it's a little hard to do it on the computer, but there we go. All right, the last thing I have to do here is highlight all of my solutions. Okay, so I'm going to use this highlighter real quick. This is saying y is less than. Less than means below everything underneath. So again, if you were standing on this line, if you pick a point and you point downwards, well, it's everything underneath this line. So I have to shade everything. Here is representing all of my solutions. Okay, all of that area represents all possible answers. All right. Now, of course, I'm going to ask you guys, hey, give 3 possible solutions to the one we just graphed. Well, give me 3 possible solutions. Some people were saying 3, 1. Yeah, would 3, 1 be in there? Yeah, absolutely. It's in the shaded area. What's another one? 2, negative 1. Absolutely, 2, negative 1 is also part of it. What if I chose 100, 3? 100 is going to be like way out of here. And then 3 would be up here. Sorry, let me get rid of that. So this would be 100. Let's pretend I went all the way over there. 3. Yeah, because this highlighted area actually keeps on going forever. Let me use my highlighter here. This shaded area keeps going, extends. I know we don't see it, but actually 103, 100, 3 would still be part of your solution as long as it's in this general area over here. All right, let's move on to our last 2 here. Okay, so example number 3. Now I want to go backwards. So it says write the linear inequality for the given graph. So I give you guys the picture. Now what I want to do is I want to go backwards. Can I actually go and write the equation? So let me go on to the next slide. Well, first of all, here we have the problem, right? And you always want to pick 2 nice points. That's where I always want to start off. I know my graph's there. Hey, that's a nice point right there. Okay, where's another nice point? That's not nice. Doesn't cross nicely. Doesn't cross. There we go. That's another nice point to use. Okay, so what I want to do here is, hey, I want to figure out what this person was doing. I know that it's in y equals mx plus b, because that's the equation of this line here, right? I always start with my b. So where did this person start with the y-intercept? Well, they started at 1, 2. So I know my y-intercept is going to be 2. Okay, now how the heck did they get the second point that I highlighted here? Well, they have to go up 1, 2, 3, and over 1. So my slope here is 3 over 1 or simply just 3. Okay, now did this person shade above or below? Well, again, if you take a point, right, they shaded below the line. If I draw arrows pointing where they shaded, my arrows are pointing down. So they shaded everything underneath that line. So I know that it's going to be either less than or less than or equal to. But I got to figure out which one, right? Is it equal to or is it not? Well, it's a dotted line. I can't stand on it. I can't equal it. So it's actually not going to be that one. I got to get rid of that one. So the symbol that I need to use is strictly less than. If I go back here and I plug in all this information that I know my equation, okay, working kind of deconstructing here, I know that it's going to be y, and it has to be less than because it was underneath. That's a terrible less than sign. I can't equal it, so I don't put the line underneath. What was my slope? Well, it's 3 over 1 or 3 because they went up 3 over 1. And then don't forget to bring over your x. Now, what was my y-intercept? What was my initial starting value? Well, it was at 2. And again, that is a positive 2, so I better say plus 2. That is what I'm looking for. If I ask you guys, what should my inequality look like? I'm asking you guys to give me the equation, well, in this case, the inequality. What was the original problem that you had to graph? All right, let's go to the last one here. I want you guys to try this one on your own. So again, take a minute, pause the video. All right, so again, I know I have the line, so I know I should be writing something in y equals mx plus b form, right? So let me deconstruct this. Well, let me pick 2 nice points because if they give me 2 of them, this one's pretty nice. That's not too bad. That one's not too bad. Okay, let me use actually a different color here. That one's not too bad. Okay, but then this one, it's between like 4. I don't want to use a decimal, so let me try to find another nicer one. Let's see. That doesn't work. Nope, 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 nope. There we go. That looks like a nice intersection. Okay, so once you have 2 nice points, okay, I can actually jump into this. Well, this person, I know that what they were trying to do here is that they started at 1, 2, 3. Okay, you always start on your y-axis, so I know that this b here has to be a plus 3. Okay, I know that much. Well, how the heck did they get the second point? Well, this person had to go down 1, 2. They went down 2, so that's a negative. Don't forget, if you go down, it's going to be a negative. They went down negative 2, and they went over 1, 2, 3. So my slope here should actually be negative 2 over 3 because they went down 2 and across 3. Now, don't forget to bring down your x. Don't forget to bring down your y. Now I have to just figure out that symbol. It's not equal to anymore. It's an inequality, right? Did they shade above or below? Again, if you kind of take anywhere on this line and you point arrows, well, these arrows are pointing upwards. They shaded everything above that line. So I know it has to be greater than or equal to, one of those. Well, if it's strictly greater than, this would be a dotted line, but it's not a dotted line, it's a solid. So this is the right symbol that I should use, not this one here. Okay, so my inequality here that I have to write is y is greater than or equal to negative 2 over 3 x plus 3. Now again, big common mistakes that I saw today. People were missing the x. Okay, they forgot to write it in there, and then the negative sign. If you go down, they were getting 2 over 3, but they were forgetting the negative to point down. All right, guys. For your reflections, remember three questions. For your reflection, this was a good thing to write in there. Explain the steps to graphing a linear inequality when in standard form. Make that meaningful, right? Your summaries reflect on what we just learned, what we just talked about. Okay, once you're done with that, here is your class activity. Numbers 1, 2, 3, and 4 is exactly what the first 2 examples that I did, and 5 and 6 are the last 2 examples that I did. Okay, I should be back before the period's over. I just have a quick meeting, so I'll see you guys back in a quick second. Make sure that you guys are working on this class activity. See you guys in a second.